this episode of Finno-Ugric machining, we are going to talk about microcontrollers and how to program them. Furthermore, or more precisely, the programming principles and programming principles. I have a list of subjects I'm going to talk about. And first of all, we are going to talk about the hardware. Well, if you want to program a microcontroller, you need to know something about the hardware. Then we are going to talk about software. What is software actually? And last of all, we are going to talk about the tools used to do this type of task. All this is very superficial. We are not going to go into very deep into this subject, just touching the surface, more like listing what you need and some of the principles. But we are going to one subject we are going to deal very closely today. It's the hardware and the relation between hardware and your software. Okay, let's start. Well, let's first talk about the execution states of your, or the power states of your microcontroller. Well, again, I have this paper here because this is very hard for me to get out of my head in a structured way. I'm a very unstructured person, so okay. So the states of this microcontroller can be coarsely divided into 4 groups. The first and very obvious state of the microcontroller is when it has no power. It's powerless. Nothing happens there. Not a single volt or millivolt is present nowhere inside. That's a no power state. Usually you don't need to worry about this state. You just don't have the power. Okay. Then the next state is when the power is switched on and the microcontroller starts to get some voltage, not enough to run, but yeah, it will be there like idling. What does it do? And this state is actually very dangerous. You need to take care that your hardware behaves correctly in this state when the microcontroller cannot execute anything, but you still have some power there. Normally this state, the duration of this state is only a few milliseconds, but if your design is flawless, if your design is not good, it will destroy something. It has happened to me many times that I didn't take good care of this state. This is probably the most harmful and the most dangerous state because all bets are off. Well, they guarantee on these microcontrollers that they have the outputs in a specific state when it fires up. Okay. Well, the next state is that the power has reached acceptable levels. The reset pin is released so that the microcontroller is allowed to run. Now, the release of the reset pin, when does it happen? Most microcontrollers today, and also the older models, contain a watchdog thing, reset circuitry inside the microcontroller, which is adequate for most uses, but I have said this earlier, and I really don't trust that one. Well, therefore I use an external reset circuitry, which is a thing that will only release the reset pin when there is adequate power supply available. Yeah, okay. So, what happens next when this power comes on? Usually the microcontroller executes what is called a power on sequence. And this one, this is the next state. It's executing. Something starts to execute, and this should result in the normal run of the microcontroller. Now it's up and running, everything is nice. Yes? Well, normally when you program this kind of device, the first time you fire it up, nothing happens. That's the normal program run. Then next, probably also very dangerous state is so-called brownout. The power supply starts to go down, and suddenly you have a situation when there is no more adequate power supply available. So now, what does our dear microcontroller do in this case? This is also very important that you program it in a way that it doesn't do any damage to your circuitry. There might be some issues with this one. I will, in the later episodes, I will address some of these. Now, the brownout may end up in two ways. The other way, the power comes back, and well, what does the microcontroller do in this case? In my board, in my board, this microcontroller will do the reset again. If the power went down, it will do the reset again. Yeah. The other way this brownout can end is a complete loss of power, and this is the normal shutdown of your device. Well, these are the states which you can encounter when a microcontroller code executes. Okay. Now, we are going to talk about the reset. The types of resets your microcontroller is probably going to execute. The first and most obvious reset is when your microcontroller is powered up. The reset line is held active until the power supply is adequate, and then reset pin is released. This is a hardware reset, generally known as POR, power on reset. How come? Quite well. The next not so obvious reset occurs when there is a brownout. When power goes down and comes back again, but doesn't go back to zero, the power is not completely off. It stays there, but is not adequate for feeding the system, and therefore a reset occurs. This is, if it is done properly, it's fully comparable with the power on reset. Well, it's not. I can tell you, it's not. Quite many of the internal registers of the microcontroller are random when it starts up like that. Yeah, they are. And then a third kind of reset is an intentional software-driven reset. And this is very different from power-up reset. The registers are retained, quite some of them are retained, and there will be, when you initialize your system, you should be aware that this kind of reset can also occur. The reasons why this occurs, the most common reason for software reset is a so-called watchdog. Watchdog is a thing that is running in the background, and if it is not frequently told that yes, I'm in good condition, I'm running, it will wake up and bite the program. Yep. What watchdog really does, it does a software reset, and as I already told, it's very different from hardware reset. Then there is a specific instruction which is also reset, and this one you can also use intentionally to reset your system. All these software type of resets are usually not desirable. Then we have fourth, very different type of reset, and this is when you start programming your device. In this case, the reset pin is held down all the time, and then the communication pins are driven in a way that the microcontroller understands that, oh yeah, somebody wants to program me. Okay, this one is the fourth type of reset. So the most important things is that the microcontroller doesn't do it doesn't distinguish between these types of resets. When you design the initialization code, that is the code that is executed immediately after the reset pin is released. When you design this code, you need to design it in a way that the end result of this initialization is the same no matter how you did the reset. So this is why you need to know a lot about the hardware of the microcontroller. Most libraries, I go to that, let's say most code that is available, for example, in the internet, they don't do this well. They do a lot of assumption on register states, etc. This is really bad. Well, I can help you there. And then, after the reset is complete, normally the program goes on with its own tasks, etc. So this is about the reset mechanisms. Hopefully that was not too obvious. Last but not least, a little bit of a talk about the tools you are going to need when programming or developing programs for microcontrollers. Well, the first and obvious thing is a computer. You could enter the program as hexadecimal code into this microcontroller, but that would be really tedious. I have done it, believe me, it is not an easy task. So, the computer is needed for the first, for a good text editor. It shouldn't be a notepad, that's really bad. For Windows environment there are quite a few free text editors. One that I prefer is Crimson editor. Nowadays it's something like Emerald editor. It has changed its name, but it's a really good one. The next thing, oh yes, I'm reading a paper. The next thing you are going to need is tool chain. Tool chain is a collection of programs needed for compiling your code. It consists of librarian, which is you are going to need that one if you are creating your own libraries. It consists of the actual compiler, which is compiling your source code into the target platform, which in this case is AVR, 8-bit microcontroller. Then you are going to need a linker, and finally you are going to need a program loader. It's a program that is communicating with the target platform, in this case your printed circuit board, and specifically there with the microcontroller in that board. So it's uploading your code into the microcontroller. Well, of course, you need something between your computer and this program, this printed circuit board. And the thing you are going to need, well, you should search internet. It's called AVR ISP, AVRISP. And it's quite simple thing. Doesn't cost much, and this is the only thing you need to invest, really. Well, there are many varieties, and I'm not going to talk about those. You will quite soon realize what is the one you are going to need. Well, about the platform, the operating system in which this tool chain and everything is working. Well, I have found out that Windows is not the best possible. The reason for this one is that the Atmel AVR toolchain was developed in Linux. There is a Windows port, but this one is, it's not actually buggy, but it's not working properly. Well, yeah, I use Linux for that reason, and well, I also avoid the bunch of security updates which are coming every week into your Windows. Well, you have security updates for Linux as well, but not so often, and they are not fatal. Okay, this was about the tools you are going to need when doing this kind of programming. Well, this was the first episode of variable frequency drive programming. In the next episodes, we are going to talk more about the interrupts, the main code, polling, and doing your stuff with the hardware. Since then, bye!